All right, how did you do? Y prime, again, product rule here. Keep one the same times the derivative of the other one, plus keep the other one the same times the derivative of the first one. For our next example, a couple of different ways you could go about this. You could, in the second one, use the quotient rule, or you could change that tan x to a tan x to the -1 and do it as a chain rule. Now, just show of hands, how many people did tan x to the -1 and chain rule? How many people did quotient rule? Okay. I'll do it both ways so you can check both your answers and see that they're the same. So I'll start with the quotient rule since it's written that way. So dy dx. When figuring out the derivative of tan 2x, it's a chain rule there because 2x is inside of tan. So we would have the outside function is tan, so you'd have secant squared 2x. Then the derivative of the inside function is times 2. Plus, then if we think of this as the quotient rule, keep the bottom the same times the derivative of the top, and the derivative of 1 would just be 0, minus keep the top the same, the derivative of the bottom is secant squared, all over the bottom squared. This would be fine. It didn't ask you to show that or anything. You could leave it like this and you would be fine. You can see that this is going to go away because it's times by 0. And you just have negative secant squared over tan squared. If you first changed the function to tan 2x plus tan x to the -1. And I'm going to put that -1 outside brackets there. You could have also written it inside, but then it might look a little bit like tan inverse or so. And this will also help us see working from the outside in with the chain rule. So we would have the chain rule for the first one. That's going to be exactly the same. Derivative of tan is secant squared. Derivative of the inside is 2. Then here, chain rule would say bring out the -1 in front, which ends up making -1 here. And then subtract 1 from the exponent would be a -2, times by the derivative of the inside, which would be secant squared x. Can you see that those two are the same? On the top of the one on the top, you have a negative secant squared and a tan squared on the bottom. Here, this tan x to the -2 would be a tan squared on the bottom, and we still have a negative times a secant squared. So either way would be fine.